Okay, so hi everyone. So today we are discussing a problem in the linker list. So here is the problem: special delete and insert. So what is that? They basically deleting a node without accessing the head pointer of the linker list. Basically, we don't have access to the linker list. Okay, like a head pointer. Usually, linker list is there. We always have a pointer to head, right, Sunil? So this time, what is happening is we need to delete a node without accessing the head pointer. That means we have access to that particular node. Okay, so how to delete a node and insert a node at a correct position in linked list of integer elements where nodes are uh, linked in ascending order of their values. Okay, so basically this is the second problem. First, let's look at the first problem. Okay, deleting a node. Okay, let's look at the okay, let's go to the whiteboard. Just a minute. Okay, let's start inking slate. We can use this whiteboard. Mm, Okay, so where is my? I think I lost my pen. Okay, let me get my pen. So you got the basic understanding of the algorithm, right? Give me
Yes,
a
sir.
minute. Yeah, give me a minute. I will get my whiteboard pen and then I will draw and explain the problem. Okay, just give me a minute.
Okay.
Yeah, let's look at the Geek for Geeks link. In the meantime, I put it in the Discord channel, right? I will come in a minute. Okay, Sunil, I am back. Okay. I think someone else is also joined. Welcome. Is that Mohit or I don't know? It says fellow Justy. So you can unmute and speak anytime. Okay, if you have any questions. So we are discussing this problem today. Okay, problem number 9: deleting a node without accessing the head pointer. So I'm going to explain on the whiteboard here. Okay. So basically, linked lists are like this, right? All the elements are linked together, right? So every element has a data and the next pointer, correct, Sunil? Okay, and here is the head. uh, so head pointer is always pointed to the first element. Okay, Sunil and Ram. Hey Ram, welcome to the uh, algorithm discussions. Ram, where are you from? You can unmute.
He's from Vizag, sir.
Oh, Vizag, very good, very good. Hey Ram, so we are discussing different problems and algorithms. So right now, today I'm explaining the problem from linker list. Okay, it's saying not supported. What is happening? Can you see my screen? Did you join from phone or laptop? Phone. Okay, okay. Better to join from laptop so that you can see my screen. So I shared my screen. Can you see my screen?
Yes, sir.
No, I'm asking. Okay, he's saying wait a minute. Probably he might be joining through. I will come back in a minute. Okay, so he's going to come through laptop. Okay. In the meantime, we'll discuss. Okay. So So our intention is to delete a node, so we don't have access to the head node. So every time linked list we have a pointer to the head node, right? So if I give you the
Yes,
pointer to the head node, we can delete any number. Let's say we want to delete number 3 or number 4. So we can navigate here and we can delete the node whatever we want, right? Now we don't have access to this head node. Okay, we don't have this pointer. We have pointer to the particular node. Let's say n point to this node. You want to delete it. How can we delete? In the linked list, deleting means changing the address, right? So changing the address here, pointing to this element. That is how we delete the elements, right, Sunil?
yes, sir.
Yeah, basically address means like this one has, let's say, 1111. Here is the 1111 in the memory. This address of this node number 3 will store here in the next pointer. Let's say this is 1234. This is the address of this node number 4 address. So what we need to do, we just need to erase this and say 1234. Then 2 connected to 4 directly. That means to delete number 3, to delete the node with number 3, what we need? We need to access the node before the deleted node, the node that we want to delete, right? So we need to have access. We need to access this node, but we don't have head node. If you have head node, you can definitely see what is the before node, and then we can change the address. Since we don't have access to the head node, how to delete number 3? Any idea how to
Mm,
delete number 3 in this situation? Because we have access to this node only. So let's say n dot next means, if you say n dot next, get 4, but there is no n dot previous. It's a single linked list, right? Single linked list, there is no back pointer, the pointer to the before element. We always have pointer to the next element, right? Are you following so far?
yes, sir.
Yeah.
Yes, sir. Yes.
So we want to delete node number 3, and we have access to that node only. It is a simple tricky question. It's not a real big algorithm. It is a simple a technique that we can do. Okay.
Okay, sir.
So any idea how to delete number 3 in this situation?
Means without accessing it means we need to store address of head node now, sir.
We need to store address of what?
Head node.
Head node. Yeah, but we don't.
Otherwise, how?
Yeah, we don't have address. We don't have.
Yes, sir.
Yeah,
Head node. How can we travel, sir?
exactly. We cannot traverse. But let's say, this. There is one more condition they are giving. We need to delete a node, and n is not a last node. There is a technique. So if n is not the last node, let's say n is not number 5, we can delete n. So that means if n is 1, 2, 3, 4, any of the nodes, we can delete. Without traversing, what we can do is very simple. We can copy the contents of, because we can access the next element, right? We can access the next element. We copy the content of the next node into the current node. That means copy the content from here to here, and then change the address of this node to the next node. Essentially, what we are doing is we are deleting this node. We are deleting this node, but we are copying the value from here to here. That means what happens? So the copy means the value here 3 becomes 4, right? And 3 connected to number 5. So here is another 4, but it will be ignored. We basically cutting this particular link. These two, right? We are cutting that link and we are connecting to the next node of this node. You got the
Yes,
point?
sir. That is, I understood this point, sir. But how can we move from head to that node?
How can we
We
move
need
from?
to delete head node to this node.
We already have pointed to the node number 3, n. See, what is the input
Okay,
is
sir.
input given is n pointed to the node that we want to delete. We don't have head is not there. Okay.
Okay, 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 sir. I got it.
Okay, so basically we have access to the node that we want to delete. So how can we delete? If it is a double linked list, it is easy. We can go back to the previous node and we can change the addresses. But if it is single linked list, we don't have a choice. We cannot delete that node. So instead of what we are doing is, since you can access the next node, we are copying the value from the next node into this node, and then we are deleting the next node. Okay. Hi Shri. Is it different, or I see Ram before? Hi Shri. Is it first time you joining these sessions? You can unmute. Yeah, Ram is also here. Hi Ram.
Yes.
Hi Shri. Okay, welcome to the data structure classes. So basically, I will
Hello.
explain a couple of problems on each concepts. I'm giving a brief intro here. So, if I am expecting to have basic knowledge of recursion, condition, stacks, view, and hash tables, stacks, and queues. If you have the basic understanding of these data structures, I will explain. I'm going to explain these deep understanding of these data structures and algorithms like arrays, matrix, strings, linked list trees, graphs. Okay, so I usually explain 5 to 10 problems on each concept. So in the last couple of weeks, I already explained arrays and strings, around 15 problems, 10 to 15 problems on arrays and strings. Right now, I am explaining the linked list algorithms. So if you are part of the Discord links, we have a Discord channel, and I keep posting all the recordings as well as the coding, links here. So please feel free to ping me. Here is my 3410 is the ID. So please join Discord, and Sunil Kumar can help you to connect here. No, wait. Just a minute. Okay, just a minute. So my daughter came here. So basically, I'm explaining these sessions, these classes every day. So every week actually. So please join our classes. So today we are explaining this program. Okay, let's look at this one. So um, we are explaining this problem today. So basically, deleting a node without accessing the head pointer. Okay, just think about it. I will be back in a minute. Okay, just a minute. Okay, guys. So I'm back. So you guys understood, right? So basically, we are explaining this problem today: how to delete a node without accessing the head pointer. So Suni, Sri, and Ram, do you have basic understanding of the linked list, right?
Yeah, Suresh.
Very good.
Bro, I'm completely new.
Oh, you're completely new to the linked list and concepts. Okay.
Everything here.
Okay. So maybe what you can do is go to recordings, watch the recordings. I will send you the links of recordings as well. So the linked list has these two things. Like every linked list has two elements basically. First one is the data element, and next one is the next pointer. Okay, this is the data part and this is the next pointer. So we always have data point. It could be numbers, it could be integers, or it could be any values or employee objects, right? All these are data. And next one is the next pointer will connect to the address of the next node. Okay, so this is how it is. So, and we always have head pointer which connects to the first node. Okay, so whenever a linked list algorithm is there, most of the times we have the head pointer. Then they will ask, hey, delete a particular node or insert a node. Okay, or count number of elements or reverse the linked list. We have different plenty of algorithms that with the linked list where head pointer always points to the first node in the linked list. Okay, is it clear, Ram and Sri?
Yeah, it's clear, sir.
Yes,
Okay.
yes.
Yeah. So now the algorithm is different. The algorithm what we are touching here is it's a little different. Look at the question here. So we want to delete a node without accessing the head pointer of the linked list. So the basic idea here is it's a very tricky question. So we don't have this pointer, head pointer. We don't have head pointer. Instead, what we have is we have a pointer n that points to a particular node. Okay, so basically if you have a head pointer, let's say if you have a head pointer and we also have a pointer to n, we want to delete, you have head, you want to delete n, so we can simply go ahead and search for this n means the node with 3, let's say. So you can start from the beginning. Is the next one is n? No. Is the next one is n? For the 2, this is the 2, this is the next one is n which we want to delete. What you can do is you can change the address of node 2 directly to the 4. That is how to delete. Basically, if you change the address of the node point which is already pointing to node 3, if you change that address to number the next node of 3, what is the next node of 3? 4, right? If you change the address of next pointer here of node 2 to 4, then 3 will automatically delete it. How it is automatically deleted? Because if we are talking about the languages C sharp, Java, or Python, all of these are languages have a garbage collection. So that means here we deleted this link. We deleted this link, right? That means no one is pointing to number 3. No pointer, like there is no variable in our program that pointed to 3. So it will automatically gets deleted after a few fraction of milliseconds. So that's how we still have the numbers 1, 2, 4, and here is 5. So we still have our numbers. We just deleted 3. But now problem here is we don't have access to the head node. We don't, so 2 is connected to 3. Now we don't have head node pointer to the head node. How to delete? We have only pointer to this node number 3. So n represents the node that we want to delete. So any ideas? How can we access 2 from 3? Sri or Sunil?
Can we do it by backtracking?
Backtracking, how can we backtrack? Because every node has two things, data and a next,
Yeah, yeah,
next
sorry, sorry.
pointer. It is always connected to the next node. You don't have a previous kind of thing. If it is a double linked list, if you know about any if you know the data structures, like a double linked list data structure has two things. Here is the data, here is the previous, and here is the next. So the previous node always connects to the previous 3. 3 connects to 2, 2 connects to 1. But here it is a single linked list, single linked list, SLL. So how can we do this? You cannot access 2 because we want to change the address of 2 to connect to the 4, but you cannot access 2. So I
I
just,
have one idea, sir.
sure, sure, yeah. I already told you the a little bit solution. Yeah, go ahead and share the idea.
Means it is different to that one, sir.
Yeah, go ahead, go ahead.
Whenever we are, yes, sir, whenever we are deleting a tail element, you
Hmm.
can think it. We want to we want to trace that previous element now.
Hmm. Yeah.
In that time, we are returning the node of second last element
Okay.
address, sir.
We are returning the second
మనము
last element.
అడ్రస్ని రిటర్న్ చేసి మళ్ళీ
Hmm.
దాన్ని సెకండ్ లాస్ట్ ఎలిమెంట్ ది అడ్రస్ రిటర్న్ చేస్తామా సార్? అప్పుడు
Yes.
దాన్ని అడ్రస్ వాట్ ఎలా
See,
చెప్పాలో నాకు అర్థం కాలేదు సార్. అర్థమయ్యేకైతే ఏంది?
no problem. ఇప్పుడు ఏంటంటే, so we have access to the we have address of this node that we want to delete, right? Another, so
ఎస్ సార్.
so if you have this kind of situation, there is a way to delete this element, as I said before. So basically, let's say one more input is there. So this is not a real, or and this is not a this is a tricky question. I don't think this is a real algorithm, because it is just a tricky question rather than an algorithm, but we can still do it. So basically, this algorithm requires, this tricky question requires one more condition. You can delete a particular node by accessing it. You cannot delete by on its own. But what you can do is, since it has the connection to the next element, right? It has a connection to the next element. How about copying the value from the next element to here? Basically, overwriting whatever you have, because you don't want three anymore, right? Shri and Ram. It's the idea here is, you can access the next element. So how about copying the values from next element to this element, and it's a duplicate. Now 4 and 4 here, let's remove this 4. So we can change this address of this node to the next element of 4, right? Then essentially what happened, the list is 1 2 4 5, isn't it? So ultimately d was 3 was deleted, but basically we did not delete node n. We just we deleted the node after n, but we copied the value of the next node into current node. You guys followed so far?
Yes, sir.
Sunil, you understood, right?
ఎస్ సార్.
So, Sri, how about you? So basically, we changed the connection. We essentially deleted the next node here. We deleted this node. We are asking to delete this node, but we cannot delete this node. In order to delete this node, we have to backtrack. We have to update number 2. You cannot go back from 3 to 2, right? That's why what we are doing is,
Getting, sir.
you got the point, right?
Yes, sir.
Yeah. Basically, we copied the value from next node to current node. That means n value, n is currently 3. Now n becomes 4. Now 3 connected to this 4, right? Now this node n connected to number 5. Basically, we are deleting this, the next node of the node that we want to delete. Okay. Now this problem has an issue. Let's say you want to delete number. Okay, let's come back to the algorithm again. 1 2 3 4 5, right? So now you want to delete, you want, and let's say n pointed to 4. We want to delete 4. What we will do? This algorithm says this is 5, right? This algorithm says copy the, this is how they connected, right? So copy the value from the next node to current node. That means copy 5 into here. That means now this becomes 5. Now 5 and 5. So now what is the next node here? What is the next of 5? Next of 5 is null, right? Because this is the last node. Correct. So what we are doing is, here we are putting null here. Whatever the value here, whatever the address here, we are putting here. That means 4 becomes, this 5 becomes the last element. So now 1 2 3 5, isn't it? So 1 connected to 2, 2 connected to 3, 3 connected to 5. So now essentially we deleted number 4. You got my point, right? So which is correct? Because this is not anymore, this is connected to number 4, connected to null. That means basically 4 was deleted. Now 5 copied to fourth element. Is it clear? Ram and Sri, Sunil?
You are not deleting the node, but instead of doing that, we are just copying the data which is inside it, right, sir? I
Yeah,
mean,
because we are copying the data from the next node into current node.
okay.
Yeah, because the problem here is you cannot access the previous node, right? So if you want to delete number 4, we essentially need to connect the 3 to this node, isn't it? Right?
Okay, sir.
But you cannot go back. This is single linked list. You cannot go back and connect or change the previous node. Since you cannot go back, you can forward, right? You can go to next element. So that's why we are copying the data. We are copying the data from next node into current node and deleting the next node. You got it?
Yes, sir.
Got it, sir.
Yeah. So now this algorithm has a problem. Let's say this won't work for this situation where 1, 2, 3, 4, 5. Now all is connected. Now we want to delete number 5. This is 5. 5 connected to, let's say this is the 5, right? So let me put it in a correct way. So number 5 here and 5 connected to null. 5 is the last element. Now you want to delete 5. How can you do this? Basically, you have to change the address of next 4 connected to this node, right? Let's say this address is 1111. So the 4 next pointer is 1111. So the 4 value is here and the address is the next pointer is 1111. So it's connected to here. So now you want to delete 5. If you want to delete 5, what we need to do? We need to make this 1111 null. Then 4 becomes the last element. So there is no way with the algorithm we just explained, there is no way you can delete 5 because there is no next node. If it is a 6 is there, you can copy the 6 into here and you can delete this node, but there is no 6, there is no next node. The only way to delete the last node is change the address of the previous node, isn't it? So this algorithm, what I just explained, basically copying the value of next node into current node and delete the next node, it doesn't work if the node that you want to delete is the last node of the linked list. This will work for 1, this will work for, the technique will work for 2, technique will work for 3, technique will work for deleting 4. You can delete 1 or 2 or 3 or 4 with the technique, but you cannot delete last node. Is that clear? Or why is it clear why we cannot delete?
Clear, sir.
Ram and Sunil?
So once explain, I can't understand that one.
Sunil, how about you? Did you understood?
Yes, sir.
So okay, I can explain Ram again. So the basic linked list has two things, right? Linked list has a data and address of the next node. Okay. So if you want to delete a particular node, you always need to start from the head and find out the previous node. So this connected to this node, this connected to this node. If you want to delete this node, you just need to change the address of previous node. Rather than connecting to this, you cancel this address and point to the next address next of this element, whatever the next address, right? Let's say this one is 1112. You just change the address here to 112. Then automatically, so the address of this node is 115. So previously it is 115. Now 115 we replace it with 112. The address of the next node of this is 112. The node of one, the address of this node is 112. So we are copying this value, whatever the value here, 112 into here. So that means this node connected to this node. That's how to delete. If you want to delete this node, you just need to go back and change the previous node, the next address of the previous node. But it is a single linked list and we don't have access to the head node. The problem here is there is no way. The problem is given like that, there is no access to the head node, which is not common, which is not common. Every time you will have access to the head node, but this time is a tricky question where we don't know the head node. So how can you do this? The only way is copying the value. We are copying the value from the next node into current node and deleting the next node. Rather than deleting the current node, we copied the value of next node into the current node because we don't need the current node, right? And we are deleting the next node by changing the address to the next node, right? So here the problem here is the number 5. If you want to delete the last element, right? If you want to delete the last element, there is no the next node value. There is no node 6 is, if the 6 is there, you can copy here. But if you want to delete the last node, right, this algorithm doesn't work, because in order to delete the last node, only thing is you have to change the last but one node. Ram, you following, right? The only way to change here is change the address of the last but one. But we don't have access to the head. We don't have, we cannot go back from n to n minus 1, or the before node of n. You cannot go back. At the same time, you cannot traverse from the beginning. So this algorithm will work only if the node, if the next node is not null. Basically, if it is not the last node, it will work for 1, it will work for 2, it will work for 3 or 4. You can delete any one of the nodes except the last node. Is it clear?
Yes, sir.
Okay, cool. That's good. So this is a tricky question in the algorithms, and let's look at the code. I can share the code. So it's not that much hard. Just a few lines of code. I will explain you once it opens. So Firefox update is going on. So okay, let's also discuss the complexity of this algorithm. Sunil or anyone can tell complexity.
Constant.
Constant, order of 1. Okay. Ram or Sri, do you think it's correct?
Actually, I don't know, sir.
Okay, that's good. That I will explain. So what he said is correct. It's constant time.
Means taking first element,
What is that, Sunil?
it maybe O of n, sir.
No,
We are
no, it is O of
we
1
want to
only. What you said is correct. Why it is O of n? You are not navigating all the nodes.
means
Hmm.
yes, sir. I am thinking like arrays. I am shifting all elements towards like that. I am thinking, sir.
No, you cannot even shift all elements. You don't have access to the head node. There is no way you can access 1, 2, 3 here. If you want to delete number 4, let's say you want to delete number 4, you cannot navigate to 1 or 2 or 3. You can only navigate 4 and 5. If you want, you can navigate from that node to the rest of the nodes, right? So it never be order of n. It is order of 1. Whatever you said is correct. So here is 1, here is 2, here is 3, 4, 5. Okay. Now you want to delete 3. Let's say this is 3. You want to delete 3. So what we are doing is, within just if we are navigating all the nodes one time, that's order of n. If you are navigating all the nodes n square times, let's say 5 into 5, 25 times, then it is order of n square. But now in this algorithm, what we are doing is, we are not navigating all the nodes, and we are simply, what we are doing, we are simply copying the next node value here, and we are copying whatever the next value here, whatever the address of next value into here. That way it will connect to the next node. It's just three things we are doing: find what is next node, copy the value, that's the first one. Second thing is copy the value of next node into current node, that's the second operation. And get the address of next node of next address, and copy here. That way we are connecting 3 to 5. That is the third operation. So irrespective of the elements, you can give million elements, you can give 1,000 elements, you can give the linked list with 100 elements. I don't care. I am just doing three operations. That's why it is order of 1. So we are not changing the our processing. We are not. So our always complexity is always think about, if are we increasing our processing time based on the input, right? Sri and Ram. So this is the intro to the complexity. How the complexity will work is, if the input is increasing, let's say if the input nodes are increased, you are taking more time, then it is order of n square. So how much you are increasing, that always depends. So here we don't care about the input, right? Because even we cannot access the previous elements. The problem here is you cannot access 1 and 2. So you are nowhere related to the input. You're always doing three operations, correct? It's a constant time. That means, let's say these three operations will take 5 seconds. It always takes 5 seconds. Million elements, 1,000 elements, 2,200 elements. I don't care, right? That's why it is constant. If it is a constant amount of time, so we don't say that complexity is 5 seconds, because it could change based on the system. If you are running in a very slow device, a phone or something, this algorithm will take 10 seconds, but always takes 10 seconds in the device, right? If you are taking another faster device, let's say it executes in 1 second. It always execute in 1 second. It's a constant time on a particular device what you are running the algorithm. That's why it's a order of one. You understood, Ram and Sri?
Understood, sir.
Very good, very good. So that's why it is
Yes,
order
sir.
of one. Yeah, go ahead, Ram. Go ahead. Yeah,
Yes, sir. Understood.
very good, very good. So now I will show you the algorithm. I hope it is opening. Come on, where is it? It's still opening my. Okay, so let me try to open the link again. I usually start at 8:30 p.m. your time, so that we can finish quickly. So yeah, join to the Discord channel. I will send all the updates. So here I'm opening. So I usually use C sharp. That is the comfortable language that I use, but it doesn't matter any language. It's almost the same thing. So here is the node class. Okay. So node, here is the class node, and here is the data. As I said, input, it could be data, could be integer, data could be characters, or it could be employee objects. We don't care. Only two things: data and the next pointer. Next pointer is another node. Basically, it is a class type of node again. Okay, the address of the next node. Okay, and here is the constructor add link is basically it will add link to the next node. So whatever the next node, it will add the link. So if you look at the algorithm here, I added 1, 2, 3, 4, 5 linked list, 5 linked lists. Okay, and so here one connected to 2, 2 connected to 3, 3 connected to 4, 4 connected to 5. I am printing the list here. Now look at this. Node without delete node without head node and 3. What I'm giving? I am giving directly n3. Delete n3. So we don't have access to n2. We don't have access to n1. We don't have, let's say this is the n1 is the head, right? N1 is the first node, n1. But what I'm passing here in this algorithm, I'm directly passing n3, right? Let's look at that algorithm. I just explained and I'm going to show the code again. This is the one. What I did, if node to delete is null, this is the boundary conditions or checks we need to do. If the node is null, return. You no need to delete anything. Basically, I'm saying like delete null. So it's another condition. You cannot delete something which doesn't exist. So node to delete is null, return. Next thing, if node to delete dot next equal to null, this is what this means is this is the last node. We cannot delete last node in this approach. We need reference to the head. In this case, if you want to delete me, if you want me to delete the last node, how to determine last node? If the next address is null, that means this is the last node, isn't it? I just explained here, right? The next address of the last node is always null. So that means this is the last node. So if you want me to delete this last node, it's not possible. So I'm saying because you cannot access the previous node and you cannot copy the address to the next node as well, right? So even if you take new node and if you put 5 here, so you cannot like it always connects, right? The 4 always connects to the node. So you need to cut this link. If you cut this link, then this node gets deleted. You cannot cut this link because you cannot access number 4. You guys followed, right? That's what here. If the node to delete dot next is null, this is the last node, we cannot delete last node, then return. Otherwise, next, this is the point. So if these two are not satisfied, that means this is a node which in the middle of the linked list. So now we need to do this. Copy the data of next node to the current node. So here is the node to delete dot data equal to node to delete dot next data. You understood? Next dot data means next node. This will give you, let's say if it is 3, the node to delete dot next will give you the 4. 4 dot data means 4 and 4. If it is n3, right? N3 dot next means n4 and data means 4. That will be copied to data here, right? And then what we are doing here is node to delete dot next equal to node to delete dot next. Basically, we are deleting the next node which has duplicate value. Since we already copied the value to the current node, then we are simply changing the address. Is it clear to everyone? These two are the main crux of this algorithm. We need to understand how we are copying the data and how we are changing the address. So this node we are not deleting. Okay, we no need to do something like this. We need to take a temporary variable free. We need to no need to do in this in Java, C sharp, because garbage collector will take care of the next node. Okay, so what we are essentially doing is we are taking the data, copying into current node, and we are also copying the next value into the next variable of the current node that we want to delete. Is it clear? Give a thumbs up if it is very clear, otherwise I will explain. Ram and Shri. Okay, I got one thumbs up. Second one, I don't know who gave this, but okay. Any questions or Sunil? Is it clear?
Yes.
Awesome. So this is the simple algorithm that will make us tricky question. Okay. So there is one more thing I want to explain. Here is the second algorithm. Insert a node at correct position in the linked list. Okay. So basically, insert a node at a correct position in a linked list of integer elements where nodes are linked in ascending order of the nodes. Basically, this is insertion sort. Okay, this is completely different algorithm. Okay, so what is meant by this is we have a ascending order of nodes. Okay, let's take the elements. Yeah, let's take the same elements. We have the similar elements like this ascending order. Let's say we have 1 here, 5 here, 6 here, 9 here, and 10. Okay, so these two are connected, these two are connected. So now if I am asking you, we have simple this, we have access to the address head, and we also the algorithm is like this: insert value 7, insert value 7. So where we need to so there are different ways to insert an element. You can insert at the head, you can insert at the last, you can also insert at the middle. We want to insert at the correct location. That means it should always be in a proper sorting order. So ascending order means 1, 5, 6, 9, 10, right? So the 7 comes after 6, isn't it? So 6 connected to, so it should be like this. Or someone else joined. Oh, Sri joined 2 times, huh? Maybe joining from a different system. So we have to connect to 1 connect to 5, 5 connect to 6, 6 connected to 7, and then connect to 9, and then connect to 10. So 7 must be inserted between 6 and 9. So these two are the nodes. We need to insert between 6 and 9, isn't it? Is it clear? The algorithm is clear? No, I mean like question. His question is clear? Sunil and
So
Ram.
could you please repeat again, sir?
So basically, we want to insert an element in a correct order. We have given a linked list of ascending elements with ascending order. Okay, all these elements are ascending order, right? 1, 5, 6, 9, 10. Ascending means like increasing order of the value. Correct. Now we want to insert an element 7 into this list. Where do you insert? 7 comes after 6, right? So we have to find the correct location where to insert. Is it, are we going to insert at the beginning, inserting at after 6 or after 10? So it should be between 6 and 9, isn't it? Is it
Yes,
clear?
sir. Clear, sir.
So we need to insert between,
So once again,
yeah.
explain that one. Can't get.
So the algorithm is given a linked list of ascending order of elements. Okay, this is the elements are in ascending order. This is the head pointed to the first element. Now we want to insert a new element with value 7. Basically, find the correct location and insert that element in the linked list. Is it clear?
So we yes sir. So we have to keep like that ascending order,
Yes,
like one
exactly.
after five, five to six.
Exactly. After inserting 7, the number should be in an ascending order again.
Okay,
Okay.
sir.
Yeah.
Right.
So,
Yes. Sir.
yeah, how can we do this? Because it's in arrays, right? Arrays you cannot do. Let's say if it is all in arrays, the problem with arrays is, let's say you have these elements in an array, right? Here is 1, here is 5, 6, 9, 10. Okay. So you still have a place in the array. The problem here is you cannot insert in this location. You need to shuffle the values, right? You need to put 10 here, you need to 9 here, and then you have a value here, then you can put 7 here. But here linked list is separate. Linked list, you no need to shuffle elements. You simply change the addresses. By managing the addresses, you can simply solve this problem, right? So that is the main beauty of the linked list. Linked list is very comfortable for inserting elements, for easily inserting elements, because it's a manipulation of addresses, isn't it? So how to manipulate the address? So what we need to do is simply, since you need to insert between 6 and 9, right? So we need to create an element with 7. So the value 7 was given. So first of all, let's create an element with value 7. Here is the element or the node with value 7. What we need to do, it needs to be between these two elements, right? So change the address of 6 to here. Basically, what we can do is whatever the address here, let's say this one here, the 9 is stored in 151, and I am giving addresses. So 6 was stored in 176. Okay, what we need to do is this, the next element of 6 has the value 151, isn't it? The 151 means connected to the node 9. Okay, so now what we need to do is, let's say this one is 181. Okay, what we need to do is, if you copy the value 151 here, 151, that means this is connected to 9, node 9. Okay, 6 is connected to 9, 7 is also connected to 9. Then you can safely remove this 159, 151, and put 181. Then what happens? This link was broken, and this 181 means this node, and 151 means this node. That's it. We solved the problem. Now 15679. The element is inserted in the correct order, isn't it? Is it clear? Basically, go to this the node before the node that we want to insert. Find the correct node. 6 is the correct node that we need to change the addresses, and then manipulate the addresses. Sunil, is it clear?
Yes, sir.
Ram and Sri.
Yes, sir.
Okay. So I'm going to show you the algorithm. Basically, first of all, we created the node and then navigate from the beginning. You have to navigate from the beginning because there is no way. Let's say I ask you to insert a value 0. then where it goes?
Data and next equal
Obviously,
to
first sir.
First element, right? Very good. So since 0 is less than all these elements, it goes to the first element. That means head will be changed. Now from now onwards, head pointed to 0 and 0 pointed to 1. That is one scenario. Let's say I want to add element with value 15. Where it goes? Here is last
Last.
10. So it goes to the last node, correct? So now 10 pointed to 15 and 15 points to null. No need to do anything because 15 is the last node. So those are the things you need to we need to identify exactly where this node goes. Is it going in the beginning of the linked list, or is it going to the middle of the linked list, or is it going to the end of the linked list where we need to insert? That is the main complexity to identify. First we need to navigate from the beginning and you need to identify. So how to identify? You need to, let's say you want to insert 7, right? So we will identify, as we will navigate until you find the next node is greater than 7. So let's see, first 7 is the one. Is 1 greater than 7? No. Is 1 next node greater than 7? One next node is 5. Is 5 greater than 7? No. Okay, 5 is less than 7. So go to the next one. What is the next node of 5? 6. Is 6 greater than 7? No. Let's go to the 6. Okay, 6 is connected to 9 in the beginning, right? Is the sixth next node is greater than 7? What is the sixth next node? Sixth next node is, until now, in the beginning, right? In the beginning, what is the sixth next node of 6?
9 sir. 9.
9. Is 9 greater than 7? Yes or no? Tell me yes or no. Is 9 greater than 7? Sunil, are you following?
Yes, sir.
Yes, right? So whenever the next node greater than 7, you stop there. So you are at the 6. You are at node 6. You are at node 6. You are comparing the value of next node. Is the next node of 6, is the next node of 6, which is 9, greater than the value that we want to insert? 7. Yes, the next node is the greater than, like bigger number than the value we want to insert. Then you are at the correct node to insert the 7, isn't it? That is the catch here. So you need to find, if the next node is bigger than the node that we want to insert, you need to stop there. Okay, that's what we do from the beginning. So whenever you looked at the algorithm, you can understand. So here is the insertion, right? So insert node, we, as I said, we have access to the head, we have access to the new node. Actually they are giving the new node completely, we no need to create any node. Okay, so here is, see, I am inserting number 10 here, I am inserting number 7 here. So I am already creating the node, I am already a fresh node is created. I am giving you the head here. Okay, now what happened here is, look at this. So we have head node and we have new node. If head is null, if the given list is empty, this is the first condition. If a head is null, return the new node, it will be the head, right? If the head is null, means there are no nodes until now, you are asking me to insert this node, then that will be the head. So you just return the, simply you return the new node. Okay, now if head dot data is greater than new node, that means head dot data itself greater. So this is the case where if you want to insert 0, if you want to insert 0, right? If you want to insert 0, head dot data is 1. Head dot data is 1, which is greater than 0, right? So you want to insert 0, but head dot data is already greater. That means first node itself has a larger value than the value need of the new node. So insert the new node at the front, isn't it? So we need to insert the node at the beginning, right? So new node dot next equal to head. So what we are doing is, basically new node, here is a new node dot that next equal to head. That means pointed to head, whatever the value. Let's say head is equal to 161. This is the address of the first node. So we are putting that 161 here. This is a new node with value 0. We are putting 161. That means this 0 connected to 1, and we are now head equal to, let's say this was stored at 191. The address of this node is 191. So we are simply saying head equal to new node, right? That's what we are doing next one. See, we are simply returning new node. Yeah, that will be the head actually. So now new node will be the head of the list, linker list. This is for the case where you want to insert the element at the beginning. Now these two are not satisfied. Let's say no head is not null. It comes here, and head data is not greater than the node that we want to insert. Then it comes here. Then we need to do the actual algorithm. That means we need to find the correct location. How to find the correct location? You need to traverse the list. There is no other way, right? You need to traverse the entire linker list and find the correct location. So how to traverse? We have to take integer. We have to take some iterative variable. If it is arrays, you will take for loop, right? For I equal to 0, very common. If it is linked list, you need to take some pointer. Let's say current is the pointer. Current equal to head. We started with pointer called current, and we started with head. Now we are doing what we need to do until current dot next not equal to null. That means current dot next not equal to, that means if current dot next equal to null means what is that? It is the last node. If current dot next not equal to null, if it is not the last node, the next node is not last node, and current dot next dot data, next node data is less than the node of data that we want to insert. Very carefully understand here. So current is the node that we are at the we are at the head right now. We no need to check with the head dot data. We already checked the head dot data. So now we are checking the next node data. If the next node is not null and the next node data is less than the data that we want to store, then simply iterate to the next node. Current equal to current dot next. That means if we go back to the board here, so current equal to 1, right? Now we want to insert 7. So next node, what is the next node? Next node of 1 is 5. Is 5 less than 7? Yes. If 5 less than 7, right? That's what we are doing here. 5. Next node data is less than the data that we want to insert. So 5 less than 7, yes. Then current becomes current dot next. That means current becomes 5. Now we are checking again. While loop goes to the top again. What is the 5 next node data? 6. 6 less than 7? Yes. Then current becomes 6. Now 6 next node. What is a 9? 9 less than 7? No. Right? That's where it becomes false. So we will this condition, current is 6 right now. 6 dot next is 7. 7 is less no, 6 dot next is actually 9. So 9 less than 7? No. Then it will break here. So now you are at the current equal to where are we? Current is right now 6. Here is current node. We compared the 9. 9 is greater than 7. That means we need to insert 7 after the current node, isn't it? Are you guys following so far? This is the main important steps. Now we either found the correct place of the node, which is after the current node, if the current dot next dot data is greater than new node dot data. Okay. If the current dot next becomes null, this could be another condition. Let's say you want to insert 15, right? All the elements are less than that 15, right? 1 is less than 2, 3 is less than 6 is less than 15, even 7 is, even 9 is less than 15, even 10 is less than 15. What happens is current becomes null. Finally current dot next becomes null. Sorry, if you are at the element 10, right? If you are at the element 10, see current dot next is null, isn't it? So now if current dot next is null, that is still fine. We will just copy that. So what we are doing is, let's say you are at the number 6. Let's assume the normal case. Okay, you want to insert 7. Now current is at the 6, right? So new node dot next equal to current dot next. As I said, current dot next value here is 151. Initially it is 151. That 151 current dot next will be copied to the new node dot next here. This is exactly what I said before. We need to copy the address of the current node into the address of the new node. Then 7 connected to 9. Okay, that is this line here. New node dot next equal to current dot next. Okay, now current dot next equal to new node. That means current dot next new node. That means current dot next new node is 181. So this current dot next equal to new node. That means 6 connected to 7, 7 connected to 9. Is it clear? These two statements are very important to understand. Ram, Shri, and Sunil.
Yes, sir. Understood, sir.
Okay? Very good, very good. So now simply return head. Simply return head. You no need to change anything. We are simply returning head. Always we are returning head. So after inserting the node, we are returning the head. If it is if the head node is null, we are returning new node. If the head node is smaller, we are returning new node, because that is the new head. If you inserted in the middle node, you no need to change anything. We did not change head here. You inserted a new node after 6, but you return the head. Okay, that's how this algorithm works. This is insertion sort. Basically, simply someone will ask you, hey, implement insertion sort in linked list. This is the algorithm. Okay. So here are the outputs for this algorithm. I will send the link of this algorithm. So let's look at the first algorithm. Initial linked list is 1, 2, 3, 4, 5. List after deleting number 3. So the first algorithm, we want to delete 3, right? Without accessing head. This is the first algorithm I explained. If we delete, then 1, 2, 4, 5. Try to delete 5. If you delete 5, right, which is last node, you will get this message. This is the last node. You cannot delete last node in this approach. We need reference to the head node in order to delete last node. So now this is the second program. This is the second list, 1, 3, 5, 6, 9. List after inserting number 2. So it 2 will be inserted after 1, right? 1, 2, 3, 5, 6, 9. List after inserting number 4. So 4 is correctly inserted after 3. Okay. List after inserting 7. Okay. List after inserting 10. Now list after inserting 9. Look at this. Sorry, inserting 0. So 0 must be inserted at the beginning. Okay. Here I inserted at the end. Here I inserted in the middle. Okay. I tried all the use cases. So that's how we have to do. When you write an algorithm, you need to make sure it works with all the use cases. Okay. So go through this. I will share the link of this algorithm. You guys can look into this and understand. So, and I will also share the video of this link. So you can the recording. So you can also watch the recording as well. Okay. So any questions on this one? Is it helpful, or oh, did I unmute? Are you guys? Is that just I unmuted? Can you guys can you understood what I just shared? Sunil, awesome.
Understood, sir.
Okay, so this is the algorithm. I will share the link of this algorithm. So you can run the algorithm. I will also share the recording of this video, so you can also go through this. So are you in the last semester of BTech, or which semester or which year? I'm going to stop recording anyway.